Hello everyone, myself Shivangi Desai, your instructor for the video series of Data Mining and Business Intelligence. Today's our topic is clustering methods. So let's get started. Before heading towards the clustering methods, we first need to discuss some of the orthogonal aspects with which clustering methods can be compared. So the first one is the partitioning criteria. In some methods, all the objects are partitioned so that no hierarchy exists among the clusters. That is, all the clusters are at the same level conceptually. Such a method is useful, for example, for partitioning customers into groups so that each group has its own manager. Alternatively, other methods partition data objects hierarchically where clusters can be formed at different semantic levels. For example, in the text mining, we may want to organize a group of documents into multiple general topics such as politics or sports and etc. Now, each of which may have subtopics. For instance, sports can have subtopics like football, basketball, baseball, and hockey. Now, the later four subtopics are at a lower level in the hierarchy than sports. Second is separation of clusters. Some methods partition data objects into manually exclusive clusters. When clustering customers into groups so that each group is taken care of by one manager, where each customer may belong to only one group. In some other situations, the clusters may not be exclusive, that is, a data object may belong to more than one cluster. For example, when clustering documents into topics, a document may be related to multiple topics and therefore the topics as clusters may not be exclusive. Next is similarity measure. Some methods determine the similarity between two objects by distance between them. Such a distance can be defined on Euclidean space, a road network, a vector space, or any other space. In other methods, the similarity may be defined by connectivity based on density or contiguity and may not rely on the absolute distance between two objects. Similarity measures play a fundamental role in the design of clustering methods. While distance-based methods can often take advantage of optimization techniques, density and continuity-based methods and can often find clusters of arbitrary shape. Next is clustering space. Many clustering methods search for clusters within the entire given data space. These methods are useful for low dimensionality datasets. With high dimensional data, however, there can be many irrelevant attributes which can make similarity measurements unreliable. Consequently, clusters found in the full space are often meaningless. It's often better to instead search for a cluster within different subspaces of the same dataset. Subspace clustering discovers clusters and subspaces that manifest object similarity. To conclude, clustering algorithms have several requirements. These factors include scalability and the ability to deal with different types of attributes, noisy data, incremental updates, cluster of arbitrary shape, and constraints. Interpretability and usability are also important. In addition, clustering methods can differ with respect to the partitioning level, whether or not clusters are mutually exclusive, the similarity measures used, and whether or not subspace clustering is performed. So let's have a look at the overview of basic clustering methods. The major fundamental clustering methods can be classified into given categories, which are partitioning methods, hierarchical methods, density-based method, and grid-based method. So let's start with partitioning methods. Given a set of n objects, a partitioning method constructs k partitions of the data where each partition represents a cluster and k is less than equal to n. That is, it divides the data into k groups such that each group must contain at least one object. In other words, partitioning methods conduct one-level partitioning on the datasets. The basic partitioning methods typically adopt exclusive cluster separation. That is, each object must belong to exactly one group. This requirement may be relaxed, for example, in fuzzy partitioning techniques. Most partitioning methods are distance based. Given k, the number of partitions to construct, a partitioning method creates an initial partitioning. It then uses an iterative relocation technique that attempts to improve the partitioning by moving objects from one group to another. The general criteria of a good partitioning is that objects in the same cluster are close or related to each other, whereas objects in different clusters are far apart or very different. There are various kinds of other criteria of judging the quality of partitions. Traditional partitioning methods can be extended for subspace clustering rather than searching for full data space. This is useful when there are many attributes and the data are sparse. Achieving global optimality in partitioning-based clustering is often computationally prohibitive, potentially requiring an exhaustive enumeration of all the possible partitions. Instead, most applications adopt popular heuristic methods such as greedy approaches like the k-mean and the k-medoids algorithms, which progressively improve the clustering quality and approach a local optimum. These heuristic clustering methods work well for finding spherical shaped clusters in small to medium sized databases. Now let's move forward to the hierarchical methods. A hierarchical method creates a hierarchical decomposition of the given set of data objects. A hierarchical method can be classified as being either agglomerative or device based on how the hierarchical decomposition is formed. The agglomerative approach, also called the bottom-up approach, which starts with each object forming a separate group. It successively merges the objects or groups close to one another until all the groups are merged into one or a termination condition holds. The device approach, also called the top-down approach, which starts with all the objects in the same cluster. In each successive iteration, a cluster is split into smaller clusters until eventually each object is in one cluster or a termination condition holds. Hierarchical clustering methods can be distance-based or density and continuity-based. Various extensions of hierarchical methods consider clustering in subspaces as well. Hierarchical methods suffer from the fact that once a step, that is merge or split, is done, it can never be undone. This rigidity is useful in that it leads to smaller computation costs by not having to worry about a combinational number of different choices. Such techniques cannot correct erroneous decisions. Now let's discuss density-based method. Most partitioning methods cluster objects based on the distance between objects. Such methods can find only spherical shaped clusters and encounter difficulty in discovering clusters of arbitrary shapes. Other clustering methods have been developed based on the notion of density. The general idea is to continue growing a given cluster as long as the density in the neighborhood exceeds some threshold. For example, for each data points within a given cluster, the neighborhood of a given radius has to contain at least a minimum number of points. Such a method can be used to filter out noise or outliers and discover clusters of arbitrary shape. Density-based methods can divide a set of objects into multiple exclusive clusters or a hierarchy of clusters. Typically, density-based methods consider exclusive clusters only and do not consider fuzzy clusters. Moreover, density-based method can be extended from full space to subspace clustering. Now let's discuss grid-based methods. Grid-based methods quantize the object space into a finite number of cells that form a grid structure. All the clustering operations are performed on the grid structure. The main advantage of this approach is its fast processing time, which is typically independent of the number of data objects and dependent only on the number of cells in each dimension in the quantized space. Using grids is often an efficient approach to many spatial data mining problems, including clustering, and therefore grid-based methods can be integrated with other clustering methods such as density-based methods and hierarchical methods. So today we discuss different methods of clustering and as well as the aspect which required to compare the methods of clustering. That's it for this lecture. Thank you.